This is sleep science drift, a place for slow thoughts and slower breathing at the end of a long day. Maybe you came here to unwind, or maybe you simply like the feeling of drifting through space while your room goes dark. Either way, settle in. There is nothing for you to do now except listen. Tonight, we travel through our own galaxy, the Milky Way, a spiral of stars and dust and darkness, turning slowly in the night for longer than the Earth has existed. If these quiet journeys help you rest, and you would like more of them, consider subscribing to Sleep Science Drift. It is a small thing, and it helps others find their way here too. Now, let's begin. The Milky Way is a spiral galaxy, and it is enormous. Its bright disk stretches roughly 100,000 light-years from one faint edge to the other. Light itself, the fastest thing there is, would need a full 100,000 years to cross it once. And it is not a flat plate, but a thin wheel of stars, only about 1,000 light-years thick, spinning in the dark. We live inside it, the way a fish lives inside the sea, unable to see the shape of the water around us. Some distances are so large that the mind can only hold them softly, the way it holds the idea of deep water. No one has ever counted the stars of the Milky Way one by one. Astronomers estimate there are between 200 and 400 billion of them. The uncertainty comes from the countless faint red dwarfs, small cool stars that are too dim to see across great distances. Each of these stars is a sun in its own right, with its own long life and its own slow death. To stand beneath a dark sky is to stand beneath billions of quiet fires, most of which we will never see. The Milky Way does not glow evenly. Its stars and gas are gathered into long, curving arms, wound around a bright central bulge like the petals of a slow, dark flower. There are 4 major arms, with shorter spurs and fragments between them, all turning together. The arms are not solid bands of stars, but waves, places where gas compresses and new suns ignite. A star enters an arm, drifts through it, and emerges on the other side, only to be caught again millions of years later. The galaxy breathes in slow waves, and each wave leaves new stars behind it. Our sun is not at the center of anything. It sits about 26,000 light-years from the galactic core, roughly halfway out toward the edge. We live in a small, partial arm called the Orion arm, sometimes called the Orion spur, a quiet side road between 2 larger ones. From here, the disk of the galaxy appears to us as a pale band arcing across the night sky, the combined light of billions of distant suns. We are not lost out here, in the suburbs of the galaxy. We are simply in a quiet place, far from the bright and crowded core, with room enough to grow. If you follow the band of the Milky Way toward the constellation Sagittarius, you are looking toward its center. The core is the densest, brightest region of the galaxy, thick with old red and yellow stars. There are so many stars there that night would never truly be dark, the sky forever glowing with the light of millions of close neighbors. Around the very center, dense clusters of stars orbit at tremendous speeds, circling something we cannot see. Whatever lies at the heart of the galaxy, it holds everything in its pull and asks nothing in return. At the very center of the Milky Way sits a supermassive black hole. Astronomers call it Sagittarius A star, and it contains the mass of about 4 million suns. All of that mass is packed into a region smaller than the orbit of Mercury, a point of such density that not even light can escape it. Yet despite its enormous gravity, it is quiet, taking in only tiny amounts of gas and dust over the ages. A sleeping giant, holding the whole galaxy together, content to wait in the dark. We know the black hole is there because of the stars that dance around it. Astronomers have tracked small, hot stars whipping around the galactic center at speeds of thousands of kilometers per second. Their paths curve sharply toward an invisible point, betraying the immense mass hidden there. One star, called S2, completes a full orbit every 16 years, sweeping close to the black hole before being flung back out again. These stars have danced around that darkness for millions of years, never once falling in. Most of the Milky Way is not stars, or gas, or dust, but something we cannot see at all. The galaxy is wrapped in a vast, roughly spherical halo of dark matter, far larger than the bright disk itself. This dark halo extends hundreds of thousands of light-years out into space, an invisible scaffolding around everything we can see. We detect it only by its gravity, by the way it pulls on stars and gas at the galaxy's edge. Without it, the outer stars would long ago have drifted away into the void. The galaxy is held together, mostly, by something we do not yet understand. If you could weigh the entire Milky Way, most of it would weigh nothing you can touch. Stars, gas, dust, planets, all the visible matter combined make up only about 15% of the galaxy's mass. The remaining 85% is dark matter, present everywhere, passing through you right now, never once interacting with the atoms of your body. It has been there since the beginning, shaping the galaxy in silence, asking nothing, revealing nothing. Sometimes the things that hold us together most are the ones we cannot see or name. The Milky Way is not still. It spins slowly, like a great wheel turning in deep water. The Sun, along with its planets, travels around the galactic center at a speed of roughly 230 kilometers every second. Even at that tremendous speed, it takes the Sun about 230 million years to complete a single orbit. Since it was born 4.5 billion years ago, the Sun has circled the galaxy only about 20 times. Everything moves all the time, but on scales so vast that the motion is invisible to us. One orbit of the Sun around the galaxy is sometimes called a galactic year. It is a unit of time almost too large to imagine, longer than the entire reign of the dinosaurs, longer than the age of complex life on Earth. The last time the Sun was in its current position, the first small mammals were only just appearing. Continents have drifted, oceans have opened and closed, entire species have risen and vanished, all within a single one of these long years. And the galaxy kept turning, indifferent and patient, marking time on a scale beyond us. The galaxy does not spin like a solid wheel. The stars near the center complete their orbits in far less time than the stars at the edge. A star close to the galactic core might circle it in a few million years, while a star out in the distant disk takes much, much longer. This means the galaxy slowly wins and unwinds itself over billions of years, the arms shifting like ripples on a still pond. Nothing in the galaxy holds still relative to anything else. Every star is on its own long journey, carrying its own worlds with it. New stars are still being born inside the Milky Way, in vast, cold clouds of gas called nebulae. These clouds are made mostly of hydrogen, the lightest and most common element in the universe, drifting in slow, cold darkness. When parts of such a cloud grow dense enough, gravity begins to pull them inward, slowly at first, then faster. The gas heats up as it falls together, until at last the core ignites, and a new star opens its eyes. Even now, in the quietest reaches of the galaxy, light is being kindled out of cold, dark gas. One of the closest stellar nurseries to us is the Orion Nebula. It lies about 1,300 light-years away, visible to the naked eye as a faint smudge in the sword of Orion. Inside it, thousands of new stars are forming at this very moment, emerging from great columns of glowing gas and dust. Some of those stars may one day have planets of their own, circling quietly in the dark. We are looking, when we look at Orion, at the place where suns are made. The largest of the galaxy's star-forming clouds are called giant molecular clouds. Each one holds enough gas to make hundreds of thousands of suns, spread across hundreds of light-years. They are cold and dark, colder than the coldest winter night, only a few degrees above absolute zero. Inside them, molecules form that would be impossible in the heat of open space, simple chemistry happening in the deepest cold. From this cold and dark, all the warmth and light of the galaxy eventually comes. Most of the stars in the Milky Way, including our Sun, are called main sequence stars. These are stars in the long, stable middle of their lives, quietly fusing hydrogen into helium in their cores. A star like the Sun will spend roughly 10 billion years in this peaceful phase, shining steadily, changing almost not at all. The Sun is about halfway through its main sequence life, with another 5 billion years of quiet burning ahead. There is something reassuring in that steadiness, a light that does not flicker for billions of years. When a star like the Sun finally runs low on fuel, it does not simply go out. Its core contracts and heats up, while its outer layers swell outward, cooling and reddening as they expand. The star becomes a red giant, 100 or even 1,000 times wider than it was before. When the Sun reaches this stage, it will swallow the inner planets, including, most likely, the Earth. But that is 5 billion years away, far beyond anything we need to worry about tonight. For now, the red giants drift among the older stars, swollen and slow and patient. The largest stars in the galaxy end their lives in a far more dramatic way. When a massive star exhausts its fuel, its core collapses in an instant, and the outer layers are blasted outward in a colossal explosion called a supernova. For a few weeks, a single dying star can outshine an entire galaxy of billions of suns. The explosion scatters heavy elements, carbon, oxygen, iron, gold, out into the surrounding gas. Every atom of iron in your blood, every atom of calcium in your bones, was forged inside a star and scattered by such an explosion long ago. You are made, quite literally, of star dust, scattered across the galaxy by ancient fire. After a supernova, the core of the dead star sometimes remains, compressed into one of the strangest objects in the galaxy. A neutron star is what remains when the atoms themselves are crushed, their electrons and protons pressed together into pure neutrons. It is so dense that a single teaspoon of its matter would weigh as much as a mountain. Some neutron stars spin hundreds of times per second, sweeping beams of radiation across space like distant lighthouses. We call them pulsars, and the galaxy holds thousands of them, ticking in the dark like cosmic clocks. If the dying star was massive enough, not even a neutron star can survive. The core collapses past every limit into a black hole, a place where matter has been crushed out of existence, leaving only its gravity behind. There may be 100 million of these stellar black holes drifting through the Milky Way, invisible, detectable only when they pass in front of something else. Each one is the grave of a giant star, a quiet, perfectly dark place at the end of a long, bright life. Stars like the Sun do not become supernova. After their red giant phase, they gently shed their outer layers, leaving behind only a small, hot, dense core. This remnant is called a white dwarf, a star the size of the Earth, but with the mass of the Sun, slowly cooling for billions of years. Eventually, it will fade into a dark, cold cinder, a black dwarf, though the galaxy is not yet old enough for any of these to exist. The galaxy is full of these slow, patient embers, stars that have already said their good night. Our Sun is not the only star with planets around it. Astronomers have discovered thousands of planets orbiting other stars in the Milky Way, called exoplanets. Most stars seem to have at least one world circling them, which means the galaxy may hold hundreds of billions of planets. Some are hot gas giants close to their suns, others are small and rocky, and some may even have oceans, perhaps even skies. Each of those worlds turns silently in its own long year, beneath its own unfamiliar stars. Around the bright disk of the Milky Way stretches a huge, faint region called the halo. It is mostly empty space, dotted here and there with old stars and ancient clusters, drifting far from the main disk. The halo also holds the dark matter that surrounds the galaxy, an unseen sphere far larger than the visible parts. It is the quiet outskirts, the cold edge of the galaxy, where the oldest and loneliest stars make their slow orbits. Even galaxies have their quiet outskirts, their distant empty places where nothing much ever happens. Scattered through the halo are dense, spherical swarms of stars called globular clusters. Each one holds hundreds of thousands, sometimes millions, of ancient stars, packed together more tightly than anywhere else in the galaxy. The Milky Way has about 150 of these clusters, orbiting slowly through the halo like distant glowing beacons. Their stars are among the oldest known, some nearly as old as the universe itself, quietly burning out their last fuel. To be inside, one would mean a sky crowded with brilliant suns, no real darkness anywhere, the night forever bright. At the center of the galaxy lies a thick, rounded region called the bulge. It is a dense swarm of old stars, roughly peanut-shaped, thickening the middle of the disk. The stars here are mostly ancient red and yellow giants, long past their bright youth, drifting in slow, crowded orbits. Interstellar dust hides much of the bulge from our view, so we see it only dimly, a faint glow toward Sagittarius. It is the old, dense, quiet heart of the galaxy, where stars have lived and died for billions of years. The bright part of the galaxy is not one disk, but two. There is a thin disk, only about 1,000 light-years thick, where most of the young stars and gas live. Around it lies a thicker disk, older and redder, with fewer stars and almost no gas. Our Sun lives in the thin disk, in a quiet region where there is plenty of gas and dust, and the occasional new star. The galaxy is layered like sediment, with the young stars on top and the old ones beneath. The Milky Way is very old. Its oldest stars are estimated to be around 13.5 billion years old, nearly as old as the universe itself. The galaxy began as a vast, slowly turning cloud of gas, collapsing under its own gravity in the early universe. Over billions of years, it gathered smaller clouds around it, growing larger, slowly taking the shape we see today. Almost everything we know, every story, every life, has happened in the last few seconds of its long, slow history. Some of the oldest stars in the galaxy are called population 2 stars. They formed from the almost pure hydrogen and helium of the early universe before many heavier elements had been made. They are found mostly in the halo and in globular clusters, the quiet survivors of the galaxy's first generations. Many of them are small, cool red stars, burning their fuel so slowly that they will shine for hundreds of billions of years. They will outlive the sun and the Earth, and perhaps even the galaxy itself. Quiet, patient stars, waiting in the dark long after everything brighter has gone. The Milky Way is still growing. Large galaxies grow by swallowing smaller ones, pulling them in with gravity and absorbing their stars over billions of years. Several small galaxies are slowly being torn apart by the Milky Way right now, their stars spilling into long, faint streams across the halo. This process has been happening since the galaxy was young, smaller clouds falling in, merging, building the great spiral we see today. The galaxy is built from smaller things, gathered slowly, over a very long time. One of the small galaxies being absorbed is the Sagittarius dwarf galaxy. It has been orbiting the Milky Way for billions of years, and each close pass strips more of its stars away into long, trailing streams. These streams wrap around the Milky Way like faint ribbons, detectable only by careful observation. In a few 100 million years, the Sagittarius dwarf will be gone entirely, its stars dissolved into the larger galaxy. It is being absorbed slowly, gently, the way a river absorbs a smaller stream, without sound or struggle. Two small companion galaxies travel with the Milky Way, visible from the southern hemisphere as soft, glowing patches in the night sky. They are called the Large and Small Magellanic Clouds, named after the explorer Ferdinand Magellan. They orbit the Milky Way at a distance of about 160,000 light-years, slowly drifting closer over time. They are small, irregular galaxies, full of young stars and glowing gas, following the Milky Way like small birds beside a great slow ship. The Milky Way is on a slow collision course. The great Andromeda galaxy, the nearest large spiral, is moving toward us at about 110 kilometers per second. In about 4.5 billion years, the two galaxies will pass through each other, their stars rarely colliding, but their gas and dust churning violently. Eventually, they will merge into a single large elliptical galaxy, sometimes nicknamed Milkumda. By then, the Sun will be nearing the end of its life, and the Earth, if it still exists, will be long uninhabitable. The Milky Way is part of a small cluster of galaxies called the Local Group. It contains more than 50 galaxies, most of them small and faint, bound together by their mutual gravity. The two largest members are the Milky Way and Andromeda, with the smaller galaxies, like the Magellanic Clouds and the Triangulum Galaxy, orbiting around them. Together, they form a small, quiet neighborhood in a much larger structure. Even galaxies have neighbors. Even galaxies belong to communities, drifting together through the dark. The local group itself lies within an enormous structure called the Laniakea supercluster. Laniakea contains around 100,000 galaxies, spread across more than 500 million light-years of space. All of these galaxies are drifting together toward a region called the Great Attractor, drawn by some immense, unseen concentration of mass. Galaxies cluster into long filaments and sheets, surrounding vast, empty voids, forming a structure called the cosmic web. Our galaxy is one tiny point of light within that vast, slow, drifting structure. Above and below the center of the Milky Way stretch, two enormous glowing structures called the Fermi bubbles. They were discovered only in 2010 by a telescope that detects gamma rays, the most energetic form of light. Each bubble extends about 25,000 light-years above and below the galactic disk, filled with high-energy particles. No one is entirely sure what created them, though it may have been a violent event at the galactic center long ago. They are invisible to our eyes, but they are there, two vast, silent arcs of energy arching over the galaxy. The galaxy is filled with a faint drizzle of high-energy particles called cosmic rays. They are mostly protons and atomic nuclei, accelerated to tremendous speeds by supernovae and other violent events. They strike the Earth constantly, several thousand of them passing through your body every second without you ever feeling them. Some of them have been traveling through the galaxy for millions of years before reaching you here. Tiny ancient particles drifting across the galaxy at nearly the speed of light, ending their long journey in a quiet room. Between the stars of the Milky Way lies a thin scattering of tiny dust grains. These grains are made of carbon, silicon, iron, and ice, condensed out of the atmospheres of dying stars. They drift through the galaxy in cold clouds, absorbing and scattering starlight, dimming the more distant stars. This is why the band of the Milky Way looks patchy, with dark lanes and rifts cutting through the glow. Those dark patches are not gaps in the stars, but curtains of dust, hiding the bright regions behind them. Along with the dust, the galaxy is filled with a thin gas, mostly hydrogen, spread between the stars. In some regions, this gas is incredibly thin, only a few atoms per cubic centimeter, far emptier than any vacuum we can make on Earth. In other regions, it gathers into dense clouds, glowing faintly when lit by nearby young stars. This gas is the raw material of new suns, slowly drifting, slowly gathering, slowly becoming something brighter. Most of the galaxy is this thin, quiet medium, the space between the stars, colder and emptier than we can imagine. Astronomers call every element heavier than hydrogen and helium a metal, even carbon, even oxygen. Old stars, formed early in the galaxy's history, have very few of these metals, because few stars had died to make them yet. Younger stars, like our Sun, are richer in metals, because they formed from gas enriched by generations of earlier stars. Each generation of stars adds more heavy elements to the galaxy, slowly enriching it over billions of years. The galaxy is slowly becoming richer in the materials of planets and of life with every passing age. The Milky Way has a magnetic field, far weaker than the Earth's, but spread across the entire galaxy. It threads through the gas and dust between the stars, shaping the great clouds where new stars are born. This field guides the motion of charged particles, including many of the cosmic rays that drift through the galaxy. It is invisible and we cannot feel it, but it has been there since the galaxy was young, quietly shaping everything within it. Even the emptiest spaces are never quite empty, never quite silent, never quite still. Astronomers have detected a faint glow of antimatter coming from the direction of the galactic center. When a particle of antimatter meets a particle of ordinary matter, they annihilate each other, releasing a flash of gamma rays. There is more of this annihilation radiation near the core than astronomers can easily explain. The source is still debated, perhaps old stars, perhaps dark matter, perhaps something else entirely. Even at the heart of the galaxy, matter and antimatter are quietly meeting and vanishing in tiny flashes we can barely detect. A few stars in the Milky Way are moving so fast that they will one day escape the galaxy entirely. They are called hypervelocity stars, and they are traveling at over 1,000 kilometers per second. Most of them were probably flung outward after wandering too close to the central black hole, the gravity of that encounter giving them a push they will never lose. They will drift out of the galaxy into the empty space between galaxies, alone for the rest of time. Quiet, lonely stars, heading out into the dark, never to return. Not every world in the galaxy circles a star. There may be billions of planets drifting freely through the Milky Way, untethered from any sun. These are called rogue planets, and they may have been thrown out of their original systems early in their lives. They drift in the cold and dark, warmed only faintly by their own internal heat, invisible to almost every eye. Whole worlds, wandering alone between the stars, in a darkness deeper than any night we have ever known. Not every part of the Milky Way is equally friendly to life. Near the center, the stars are too crowded, too violent, with frequent supernovae and intense radiation. Far out in the edges, there may not be enough heavy elements to form rocky planets like the Earth. In between, in a region called the Galactic Habitable Zone, the conditions may be just right. Our Sun lies quietly within this zone, in a calm region, far from the worst of the galaxy's dangers. Astronomers can read the history of the galaxy in its oldest stars. By studying the chemical composition of ancient stars, they can tell which early clouds and small galaxies merged to form the Milky Way. Some stars have chemical fingerprints that match long-vanished smaller galaxies, absorbed billions of years ago. The galaxy carries its own history written in starlight, slow and patient and complete. Every old star is a small archive, a quiet record of where it came from, kept in the dark for billions of years. If you could travel at the speed of light, the fastest speed there is, it would still take you 100,000 years to cross the Milky Way. Nothing we have ever built moves anywhere near that fast. The fastest spacecraft ever launched would need hundreds of millions of years to cross the galaxy. The distances are simply too large, the speeds too slow, the time too long. We can only ever see a small corner of the galaxy directly, and the rest we must imagine slowly in the quiet. For most of human history, no one knew the Milky Way was a galaxy. People saw it as a band of light, a river, a pathway, a spilled streak of milk across the sky. Only in the early 20th century did astronomers realize that this band was the view from inside an enormous disk of stars, and that the faint patches in the sky were other galaxies far beyond our own. We are living in the first small moment of human history in which we truly understand where we are. a pale band of light across a dark sky, and 100 billion suns. The Sun will spend its whole life inside the Milky Way. It was born here, in a cluster of sibling stars that have long since drifted apart. It will grow old here, slowly brightening, eventually swelling into a red giant. Long after the Earth is gone, its small remaining core will cool quietly for billions of years, drifting through the galaxy it has always known. A long, quiet life, lived entirely within one slow corner of the Milky Way. From a truly dark place, far from any city, the Milky Way can still be seen arching across the sky. It looks like a faint soft band, sometimes brighter, sometimes darker, threaded through with stars. Most people alive today have never seen it, because the lights of our cities wash it out. But it is always there, turning slowly overhead, whether or not anyone is watching. A quiet glow, the combined light of billions of distant suns, waiting above the noise of our bright small lives. One day, far in the future, the Milky Way will grow dark. Its gas will slowly be used up, fewer new stars will form, and the great spiral will fade into a quiet field of slowly dying suns. Eventually, only the small, cool red stars will remain, burning their fuel so slowly that they will shine for hundreds of billions of years. And one day, even they will go out, and the galaxy will drift in darkness, its mass still there, its slow turning still going on. But that is so far away that no one alive now, no one who will ever read these words, needs to think of it tonight. For now, the galaxy is bright and warm and turning, and we are here, inside it, resting in one of its quieter corners. And so our slow journey through the Milky Way comes to an end. Past its turning arms, past its quiet dark heart, past the stars being born and the ancient stars slowly burning out, past the unseen matter that holds it all together. We have traveled nowhere tonight, of course. We are still here, in our quiet corner of the galaxy, exactly where we have always been. And yet, in our minds, we have drifted very far. There is no need to drift any further now. Let the galaxy keep turning, slow and patient, far above the roof. Let your breathing settle into its own long rhythm. The stars will keep their watch. You can rest. This was Sleep Science Drift. Sleep well.